Hey, welcome Shubham. Today we will have a front-end interview focused on React, JavaScript, and a bit of HTML and CSS. I'll ask both theoretical and practical questions and just a few mini coding ones. Are you ready?
Yep, I'm ready.
Let's go. Okay. So let's start with the HTML. How would you make your HTML accessible to screen readers if you have any custom elements?
Yeah, we can use role, ARIA label, this kind of ARIA attributes as well. And we can use proper semantic tags. So we should use semantic HTML elements like section, article, site, these kind of elements we should use. Also, we should see if the interactive elements have the tabbing behavior, like the tab index or it's set or not. If I build a custom button with a div, so I'll add a role button on it so that the screen readers will treat it as a button. As I said, all the focusable elements should have the all the relevant properties set on it. So yeah, that's how we can see it as a keyboard accessible or not. Also, the visual contrast should be good, like the foreground text and the background still should have sufficient contrast.
Okay, good. So you have the UL element with 10K items. Okay, you have a UL with 10,000 items. The page is very much laggy. You can say 10,000 LI elements in that, right? So what can you do without changing the backend pagination? So the possible answer is you would introduce backend pagination, but we don't have option to do that. So how will you solve this?
Yeah, so in that case, we can use lazy rendering, or the concept is called virtualization. So in React, we have libraries like the React Window or React Virtualized, which handle this efficiently. So basically, the idea is we should render only the items that are visible in the viewport and will not add the DOM elements that are not in the viewport or the visible area of the web page. So it will reduce the DOM size, and it will be yeah, a smooth experience. So yeah, this is about this question.
Cool. Let's talk CSS. You have a sticky header that should stay on the top. Okay. So you have a sticky header that should stay on the top while scrolling. Sometimes it flickers or collapse when new elements render. What could be happening behind this?
Yeah, that's a classic behavior whenever we have the absolute position elements. So that's because of the stacking context. So we have z indexes, and the z indexes also have the stacking context, like what is the parent. It also depends on that. So sometimes a new stacking context is created because of the transform or like position properties on parent elements. And setting a proper z index and ensuring position sticky, we can check that. And also we can check if parent have the overflow hidden or not, or like that kind of thing. So we can fix these kind of issues by this.
Nice. Tell me, if you had to make a responsive card layout that always shows exactly three cards on desktop, and two on tablet and one on mobile. So how would you do it cleanly? If you understood my question, we have to show layout in which three cards should be displayed on desktop, two on tablet and one on mobile. So how would you do it cleanly?
Yeah, so in this case, I'll use CSS grid. So in grid, we have control over how much columns to show. We can use media queries as well, but I'll go with the simple grid so that we can place the breakpoint in the min max is itself, so that we can put some pixel limit there based on the breakpoint. And yeah, so we can make it auto fit up there. So shall I write the code for it?
Yeah, you can present it.
So we can have about grade as a the class, and in that we can place display grade. Okay, and we can have grade template columns, and here we have to repeat the column, so we cannot hard code it, right? So for that we'll use repeat, and in that we have to place auto fit, as I said. And there in the second we can have min max. Okay, min max, and we can give it 300 pixels and one path. So it's the basic unit generally used in the grids, and we can also place some gap maybe. So like one break. Yeah. So this is how we can do it, and we can also tweak the breakpoints, just like this.
Okay. Nice. Can you center a diff horizontally and vertically without using the flexbox or grid? So most of the days, people know the way of using flexbox and grid, but without using them, do you know it?
Yeah, I can try. Like we can use the absolute positioning and transform to do that.
Okay. If you can try in the code area, depends.
Yeah. Okay. So we have a parent here. Okay. So we can set code C shape and it should be relative. Okay. I'm writing in the JS style. Okay. Relative. Okay, and there will be a child that we want to, I mean, center vertically and horizontally. So what we'll do is position absolute. So this will be absolute, and it will take the parent as the relative position for this, and we'll place top 50% maybe. Okay, and left 50%. So it will be top and left is for the dimensions to center it on the screen, and we can make it transform transform translate minus 50% on the x-axis and minus 50% the y-axis. Yeah. So this is how we can do it.
All right. Let's get into JS now. So here is a newish problem we have. What's the difference between structured clone and we can clone the object using JSON parts and JSON string defined, right? So what is the difference between these two ways of cloning the object?
Yeah, so structured clone is a newer API. It's a newer tool that deep clones the object safely. So it supports more types like dates, maps, sets, and handles the circular references as well. But in case of JSON stringify, if the object has the circular references, it will throw error. So it's not that safe. So structured clone is good for cloning the objects in my opinion. So in also in the JSON stringify we lose the functions undefined and also like symbol types and all.
Let's say you have a function that returns a promise. Okay, you have a function that returns a promise, but sometimes it rejects with a network error. Okay, sometimes it rejects with network error, and so you just want to retry automatically whenever it's failed. So how would you implement a retry logic and with exponential backoff? Do you know about the exponential backoff?
Yeah, I think exponential backoff is in which the timer or the delay increases with the repetition.
Yeah, exactly, exactly. That is exponential backoff. So, would you like to try it?
But yeah, I can try that. I'll start writing the function. So it returns the promise. I'll start with the async function, and so as we are retrying, so retry, and in that we'll take the function because the function that we want to retry. So retry is the parameter which is kind of the default value will take 3, so it will uh, retry 3 times. Otherwise we can pass any value there, and also the delay, the default delay that we have. So let's keep it 500 milliseconds. Okay. Uh, so what we can do is we can use by try catch here, because by this try catch we can judge that it is uh, uh, succeeded or rejected. So this whenever it is failed, it will go to catch block, and the try it's straightforward that will return uh, the function clock. Okay, so whatever it is returning will just return it. In the catch block the real game happens. So what I do is I'll try if the retries are there or not, like retries are left or not. So retries less than equal to 0, uh, then I throw error, right? Because uh, in that case, I don't have the uh, retry is present. In if the retries are there, what I do is I'll retry it again using new promise. Okay, R to get like is the result, and here we will pass the set timeout. Okay, so we'll pass set timeout here, and we'll pass the resolve, and we'll pass the delay. Okay, so this step basically is doing is it just waiting. Okay, waiting for the delay. That's why it is just a waiting step of the given delay. Yeah, after waiting is done, we can just return the thing recursively like retry, and here we'll pass the function again because we have to retry it, and yeah, this time we'll pass the retries minus 1 because we have to make it 0 at the end, and also delay. So herein this is the exponential step where delays are increasing. So each time will increase delay into 2, or we can just make it retries as well, like whatever you try here. So yeah, this is how we can do it possibly. Very nice, Shubham, you have done it correctly. So what's your favorite real world use case for the abort controller TBI? Yeah, in React apps, especially when fetching data using uh, uh, or during the component re-renders, we can use abort controller to cancel previous fetch requests. So to prevent race condition or memory leaks. So I have created one video for memory leaks recently. In that also I have mentioned this. So between the renders, we should not keep the APIs calling. In that, we can use the abort controller in the cleanup function so that between the renders, the requests will be cancelled. So yeah, this is the real world use case for avoiding memory leaks and performance boost.
Okay, this is nice. Also, explain the difference between debounce and the throttle in plain words.
So debounce waits until the pause in activity, like you can consider a search input. So we are typing something, right? So if we are taking some pause, then the function will be run. It can be API call also, correct? But and if in between, like the pause is of 3 seconds, but in between, if we add some another letter, it cancels that timer and registers a new timer. But in throttle, it is more strict. So in suppose the throttle is like in 5 minutes, will only allow 5 gigabytes. Yeah, just like that. So throttle limits the frequency of executions. Throttle limits the frequency of function execution. So just like we have rate limiting, right, in the backend, just like that, throttle is there. So yeah, yes, correct.
So can you write a simple debounce function? Just write the simple one, like don't go into many edge cases.
Yeah, sure, I can write. So the let's write function the box. It will take a function and a delay. Okay, so this is the delay. Let's take a timer which will have the timer ID registered, and which will return another function. Okay, and in which we'll pass the real args of the function, the fn. Okay, here we'll pass the real arguments of which will be passed to this function eventually, and here we'll clear timeout because whenever we are rerunning it, we need to clear that timeout. Clear timeout, and here we will pass the timer. So this is basically an example of closure where this debounce is a outer function where we are storing this timer, but even after the debounce has done executing, this inner function will have the access to the timer. So this is a closure, and also we'll register the new timer as I said whenever we call it within the time. So this timer will be again a set timer. and this will add fn dot apply. So we add will apply because we are using these functions, and also the function can have its own this, so we'll add the context to it and we'll bind it using the apply, and will partly args as we are taking here, and also in the set timeout we'll add the delay that is provided. Yeah, so this is the normal debounce function.
Yeah, great, Shubham. Great. So let's shift to React now. So here is a question that even experienced devs sometimes miss. What's the difference between use effect cleanup and use layout cleanup timing?
Yeah, so yeah, it's a bit tricky, but yeah, I'll try to explain. So use effect cleanup runs after the render is committed to screen. Okay, so committed means the DOM manipulations are done applied to the screen asynchronously. So use effect is asynchronous. So use layout effect cleanup runs right before the browser page. Okay, so the use effect is after the render is done, but use layout is before the browser page, and it is synchronous. So it is used when the DOM measurement or layout sync is needed. So yeah, this is about use layout.
All right. You have got a React app where one heavy component re-renders too often. Okay? One heavy component re-renders too often because of the parent re-renders. So how would you optimize it?
Yeah, this is a classic use case. So in this we can wrap that component with react memo. Okay, so when you only when the props really change, it will render. Also we will check the prop changes with shallow comparison, and also if the props are function, we can use compare. And if we are using or we are passing objects or reference data types like arrays to the as a props, in that case we should use memo, and we should not directly pass them, because it will be treated as new props each on each render. So yeah, and also like the context also triggers unnecessary renders. So splitting the context will help, and not everything will have single context.
Oh, good answer. So let's say you are using context API for theme. When you switch the theme type, the whole app re-renders. How can you prevent that?
So what I can do is I would memorize the or cache the context value properly, or otherwise I'll split the context into smaller parts, like one for the theme and one for other like color palette, to reduce the render scope. Otherwise, there are like other some frameworks are also there, like Zeus and or we can use Redux as well, so that everything will not be re-rendered.
Soon, do you know about React 18 plus features?
Yeah, I have heard about it, and yeah, I know.
Okay, so what's the difference between server components and client components in React 18 plus?
So server components run on the server. They don't include JS in the bundle. Okay, so basically they render on the server itself. So they have access to the server resources like database calls and all, and also they are faster because server has many resources. The client components run in the browser, so they can have interactivity and can use the hooks. The server components cannot use hooks. So we should use client directive for the client components. Yes, so this is about server and client components.
Okay, so let's go practical. Your component fetches data or not. Okay, whenever the component is prompting, your component fetches the data. Sometimes the user quickly navigates away, right? So how do you avoid updating unmounted components? And uh, will React update that unmounted component?
So no, React will not update the unwanted component, and it will in fact give a warning that cannot update or yeah, cannot update state on unwanted components, something like this. And also we can use abort controller, as I said earlier. Also, like we can use abort controller, or we can use a flag like a variable which has a boolean, which is earlier it is true and later it is false. So using that also we can make it so that whenever the component is unmounted, we can stop that API call.
Okay, let's try some coding version. So I want you to implement a custom hook that is use local storage, which will take key and the initial value. Uh, okay, it will take key and initial value, and that syncs state with the local storage. Okay. So basically, you have a state right using use step. So use local storage if you use, it will sync it with the local storage. Do you want some time for this?
Sure, I can try. So shall I use the same code editor?
Yeah, we can use it. I don't expect it to be functional, but I just want to test the logic.
Yeah, okay. So what we can do is the hooks are generally just the normal functions. So function use local storage. Okay. So in this, what are the parameters? Sorry.
These are key and initial value.
Okay. Key initial value. Okay. And okay. So in this, we can use the use state on const value set value and okay here use state we can use yeah so use state also has a default function that is kind of initialization of the state value, so we can use in this case. So we can grab the stored value first, stored. So that will be taken from local storage dot get item. Okay, and we can pass key here, and also we can return so that it will be set in the use state. So return if the stored value is there, we can pass it JSON because the local storage has the string values stored. Otherwise, we get the initial. So we will get the initial value here. Yeah, and we have to sync it with the state. So we'll use effect here with the occupancies in it. Okay, so local storage will use it here. Local storage dot get item. Sorry, here we have to use offset item. Okay, we have to use set item, and in this we'll use key. Bring the JSON dot for string the point. We pass the value itself, and whenever this key or value changes, it will sync it with the local storage. Yeah, and we can return the same like this. So we can use it like this: const value or data uh, and set data, and we can use local storage, and here we can pass app store and some initial value there, like so stored. Yeah, so whenever we'll use set data, it will just sync it with the local storage. So this is how it will work.
Okay, that's nice. Shubham did it fast. So imagine your React dashboard has a slow initial load. Okay, so you have a dashboard where we have the numbers and charts and API calls. So it has slow initial load, even though the bundle size seems fine. Okay, what's your debugging approach for this?
Okay, so first I would check if the network API calls are blocking the rendering or not. Maybe some infinite render loop or something is happening or not. I will check that. Then I'll check the large dependencies via like Webpack or bundle analyzer. Then also I'll ensure like code splitting is done or not, or how the API calls are sequential or they are like done at the same time, and if a single API is there, it will block the rendering unless until the data is uh, received or not. So this kind of factors I will check. Also, I will check if the dynamic imports are used or how it is done, and also suspense lazy loading is used or not for like heavy components. that I'll check. Also, I can use React Profiler to measure the render techniques and identify the heavy components that take much of the time.
Great jobs on you have handled the fundamentals, performance, and React hooks really well. Any areas do you find you would like to improve on?
Yeah, maybe decode on the TypeScript patterns in React, and also some thought on the accessibility related topics I would like to learn about, and yeah, and also the React testing library.
Yeah. Nice. So that's exactly what we'll test in the next round. So yeah, we'll test you more in depth in the next rounds and next videos. Just watch this video, find the interview completely, and this playlist is very much important for the guys who are preparing for the interviews. Definitely, they will crack the next interviews watching these questions.
If you enjoyed this advanced React interview, drop in comments what topic or what role you want the next. Maybe a 5+ year system design one or a TypeScript heavy round. And don't forget, code along, note all these questions because these are curated from the real interviews. Pause the video and think before listening to the answer. So that's it for today. See you in the next round.